like SMTP, SNMP, and NTP. So by now in the program, I've seen the schedule, and probably most of you are technical team members who are working on the RailTel network or RailNet network, because I've been associated with railways for a very long time. In my previous organization as well, we have done a lot of projects. We've done some trainings with ERISET and RailTel as well. So I have some close association with railways as a whole body, and it's a great organization. A lot of systems are in place where employee has to upgrade his skills and knowledge, through various training programs offered internally. And I'm happy to associate with RailTel. Okay, so coming to this topic today, can somebody use the chat window to see if you're able to hear me or my voice is okay? Can have some chat message? Or should I increase my volume? All good? Yeah,
good,
thank
sir.
you.
All good. Okay, sir. All good.
Thank you. Thank you. Yeah. So routing protocols, we're going to start off. Actually, the topic is redistribution. That's the topic. But redistribution can happen only if we have some good understanding about the routing protocols. So let's start with the concept of what a routing protocol is and why routing protocol, and then we'll go to the actual topic. So in today's world, data is everything. So the meaning of this statement is, without data, nothing can happen. Which means, so simple example, today, this morning, Wednesday morning, 19th August, we would have got up from our sleep, and daily routine we have. But I believe out of this audience, at least or minimum 50% of us would have checked our WhatsApp messages within the 5 to 10 minutes of waking up. You agree with me? I have done that. I do that every day. Why? The question is why? Can't we stop ourselves from watching WhatsApp message? We can, but we got accustomed to it or used to it, or it became a habit daily basis. But how did we get that message? Who sent that message? How did they send the message? How that message has come to you? So all this is with respect to data. That's why I use the term data is everything. In today's world, data is everything. I think some politician or somebody used this word. Earlier we used to say roti, kapda, makan. But now they say roti, kapda, makan and internet. It is an essential part of our life today. So for us, data is everything. But how this data move from one place to another place, from one computer to another computer, from one phone to another phone. Okay, so that's where the routing protocols come into picture. So every organization, irrespective of the size, it's business or organization, irrespective of the size and location, is dependent on data network, either internet or intranet or both. Some companies want only internet, some companies want only intranet, some companies want both internet and intranet. So most of you may be already aware of what is the difference between internet and intranet. Internet is public network where we access internet like browsing and chatting and WhatsApp and all this come under internet. Intranet is specific to that organization only. Outside users cannot access that network, and intranet users cannot access outside network. And that happens every day for them. Okay. So the routing protocols help data communication from one network or office to another network or office. So these protocols are categorized further into two types called static routing and dynamic routing. So we started off with what data is, how it is being used within the organizations, and that data to move from one organization to another organization, from one office to another office, we need the help of routing protocols. So this is a backbone. One is physical network connectivity. Means we have a lease line, we have internet line. Maybe in olden days we had dial-up line. Now we have mobile internet, 3G, 4G, 5G, whatever. So these are all the connectivity technologies. On top of this, we have network technologies. So if you remember the OSI layers, routing protocols, they all come under layer 3. Switches come under layer 2, routing comes under layer 3. So the routing protocols categorized as static and dynamic. So the dynamic routing protocols, there are some examples we have. RIP stands for Routing Information Protocol, EIGRP, OSPF, BGP. These are the popular. I mean, popular in the sense EIGRP, OSPF, and BGP are very popular. And those companies, organizations who use Cisco products, EIGRP is widely used. OSPF, as the name says, open standard, means I can use this on Juniper routers or Cisco routers or Nortel routers or XYZ routers also. Similarly, BGP is also an open standard protocol. So in a network, routers exchange information only with similar protocols. So this is a very important point. Like for example, the medium of instruction of this particular session is English. So a lot of us understand, or maybe Hindi, let us say Hindi. So that's a language which people can relate to, understand. Similarly, if I have a small network, just to give you an example. So we have a router here, and this is one network. So we have another router here, this is another network. So how do we know that they are different networks? So observe closely in the picture, we also have IP addresses, 172.16.1.0/25. This is a subnet mask. But if you go deep, if you observe carefully, this IP belongs to which class? Can somebody in the chat window can tell me which class of IP address this is?
Class B.
Yes, this is a class B IP address. And what is the subnet mask, default subnet mask for class B?
16/6.
Very good. Okay, but we see a different number here. We don't have a default number, we have a different number. So this comes under the concept called subnetting, meaning one network we are dividing into multiple smaller units. Okay, so why I mention that is, if you see closely the right side segment, the R2, router 2 segment, where there is host 2 and host 1, if you observe closely, the first two octets look similar. But you should not confuse that they look similar, so they belong to the same network. No, they are not. If you observe closely the octet number 3 between the R1 network and R2 network, the second octet values are different. So the subnet mask differentiates. Okay, yeah, point taken. But actually the topic for today itself is about redistribution, SNMP and NTP. I would love to, but I have already made this presentation. Okay. We'll also discuss about BGP after we complete this. Yeah. Thank you. So subnet mask is the differentiating factor here, where we want to say that this is one network and this is another network. So to allow communication from network 1, which is host 1, to host 2, we need some protocol. It could be static, it could be dynamic, it could be anything that we have mentioned earlier. Any of these protocols can be used, or static routing can be used, or default routing can be used. So if you look at the diagram, the routers R1, R2, R3, R4 should be configured with a similar routing protocol. Suppose if we use RIP, we should use RIP on all the protocols. If you are using OSPF, we should use OSPF on all the routing protocols. If you use EIGRP, we should use EIGRP on all the routers. Sorry. So only then we will be able to establish communication. Suppose if I start speaking in French or German, maybe most of you may not follow because that's a language which you don't understand. So that's the reason why we have to ensure that there is a common protocol or same protocol used on all the network devices. But certain big organizations might have started as a small organization initially, and as they grow, they would have used different protocols. So to ensure that there is communication within the network or throughout the network, we have to enable the process called redistribution. So what do we mean by redistribution? It is a process of advertising routes of one routing protocol that are learned by some other means, such as by another routing protocols like static route or directly connected routes. Means exchanging of routes from one protocol to another is called as redistribution. And it is very important for all large organizations, especially for service providers. Service providers depend on redistribution because they have to use different protocols within themselves or with the customers also. Even between customer and service provider,
Jay, I'm not getting his voice. Are you getting?
No, not getting. No voice. No voice of Gangaraj sir. So no voice, sir. Gangaraj sir. He is not muted also. There is maybe some issue. Mic is not in muted condition. Mute condition.
hello.
Yeah.
I'm sorry for the disconnection. Yeah. Okay. So to understand redistribution for a large organization, already I've just mentioned X routing protocol is used, and they expand further. They may be using different protocol. So no two protocols exchange the routes directly. Can you hear me now?
Sagar, keep watching.
Okay, sir. Can you hear me?
Yeah, please go ahead, sir.
Okay. Yeah. Thank you. Yeah. So only with the help of redistribution, we can exchange the routes from another. So I'll give another example here. Suppose you want to travel from India to some country. Let's say you want to go to US. Okay. So in India, we use currency INR, Indian rupees. And in US, you use US dollars. So when you travel, you carry Indian rupees or dollars?
Dollars.
We have to carry dollars. So what do? We go to the foreign exchange office, we give Indian rupees, they give US dollars, and we carry this to US. So similarly, if one part of our organization network is, let's say, go back to this diagram. Let's say R1, R2 are using OSPF. R1, R2 are using OSPF, let's say. This part of the network is using OSPF. And this part of the network is using EIGRP. Okay, this is OSPF. And this is using EIGRP. So there are two different protocols. So they don't talk to each other directly. They don't exchange the routes of OSPF to EIGRP and vice versa. So we have to configure the concept of redistribution. So there are certain rules that we have to follow while redistribution. Okay, so with the help of redistribution, the routing protocols can exchange the routes from one to another only with the help of the concept of redistribution. So we have certain concept here. You can see routing protocol redistribution is the process of exchanging the routes from one to another. It could be from RIP protocol sending the routes into OSPF. So what happens is OSPF protocol will learn the routes that are learned by RIP. Similarly, or we have another example, EIGRP protocol sending the updates or routing updates to RIP protocol. So RIP is learning from EIGRP. Or it could be another example, OSPF protocol sending its routes into EIGRP. We're only talking about one protocol sending the routes to another. So this concept is called as redistribution. But this redistribution is available in different ways. Performing redistribution. What we see in these examples are one protocol, RIP, sending the routes into OSPF, or EIGRP sending into RIP, and OSPF sending into EIGRP. So what we have seen, that example is called as one-way redistribution. These examples that we have just seen, all these are called as one-way redistribution. You are sending routes of one protocol into another. So one way only, one-way traffic. Means we have converted Indian rupees to US dollars, one way. Then we also have the concept of two-way redistribution, where if you exchange the routes of RIP into EIGRP, you're sending the routes from RIP to EIGRP. This is one-way redistribution. Again, sending EIGRP routes into RIP. So when you send both ways, it is called as two-way redistribution. So later, after you reach US, you spend your time, whether business or personal or vacation. And when you're coming back, you change back your US dollars into Indian currency. So this is called as two-way redistribution. So depending upon the need or requirement within the organization, the administrator can choose either to use either one-way redistribution or two-way redistribution, depending on the need. Okay. But the rules will remain the same, and there are certain precautions that we have to take, especially while two-way redistribution. One-way redistribution does not create many issues in the network, but two-way redistribution, if done, we have to be very careful, because it can lead to forming routing loops. It can lead to forming routing loops, which can create network disturbances. So we need to be very careful. So we have seen what a routing protocol is, types of routing protocols, and the need for redistribution and types of redistribution. Okay, so any questions so far? Okay, so let's proceed. Since the design of the routing protocols are different from each other, means how the RIP protocol works, how EIGRP protocol works, how the OSPF protocol works. Each protocol has a unique design, and there are different rules they are governed by. Every protocol, the way they work is different. So we need to take a lot of care while redistribution is configured. Should take a lot of care while providing redistribution. So if not configured properly, so this is the important point here. If not configured properly, routes will disappear. Now this applies to one-way redistribution also. This rule applies to one-way redistribution also. From the routing table, the routes will disappear. After redistribution, the routes will disappear from the routing table. And hence, there will be no reachability, means there is no data movement from one network to another network. So some of the parameters that should be considered while configuring redistribution are called as metric and cost. So these are the parameters that will be available for dynamic routing protocols, and they are important to be taken care while providing the or while configuring the redistribution. So examples of the metrics for protocol EIGRP. Bandwidth is one metric, delay is one metric, load is one metric, reliability, and maximum transmission unit, short form is MT. These many different metrics are governed by this EIGRP protocol. These many metrics are governed by the EIGRP protocol, and every parameter is important while redistribution. But out of these five, metric calculation formula uses only two parameters, that is bandwidth and delay. Only bandwidth and delay are the two metrics which are used for the calculation. How do we know which is the best protocol? OSPF or EIGRP or RIP? For that we have administrative distance. There's a feature called as administrative distance. The short form is AD. AD or administrative distance determines which protocol is better, RIP or OSPF or EIGRP or BGP. Okay. So in the case of OSPF, the interface bandwidth plays an important role for metric calculation, and RIP is just only a hop count. Hop count represents the routers, suppose if they are connected one to another. Sorry. So this is called as R1 connected to R2. This in turn is connected to, let's say, R3. So for data packet to move from R1 to R3, so when a packet moves from R1 to R2 is called as one hop. And packet moves from R2 to R3 is called as second hop. So this hop count is the metric for RIP protocol. Whereas OSPF and EIGRP do not consider hop count. They only consider other parameters like bandwidth, delay, etc. They don't use hop count. Only RIP protocol uses hop count. And these metrics are important for redistribution. So as we have observed in the previous slide, the metrics are different for different routing protocols and they don't match. So if you observe carefully, OSPF metrics are bandwidth only. EIGRP metrics are minimum bandwidth and delay. They are not common, they are not same. There is a different parameter in the metric. And if you compare with RIP, only hop count. They don't consider bandwidth or delay or other parameters. So since each protocol has a different metric, we have to ensure that in the time of redistribution or while configuring redistribution, we have to take additional precautions. So some protocols require additional parameters for redistribution configuration. We cannot just say protocol, redistribute your routes to the other protocol. That doesn't work. We have to ensure that they are provided additional parameters so that the routes do not disappear. We already mentioned earlier also, the routes disappear if you don't provide the proper parameters. Where did we mention that? Yeah, here you can mention the point number 2. You see here, the routes disappear if not configured properly. So the same thing we are referring to here. We have to ensure that these additional parameters, and these additional parameters are nothing but the metric. These additional parameters are nothing but the metric of the protocol. So we're going to now look at the first example of how to configure redistribution of static route into OSPF. So one is a static routing protocol, other is a dynamic routing protocol. Static routes do not have any metric. OSPF has metric. So redistribution of static routes to OSPF need when one or more static routes need to be propagated over to OSPF. Means when we want to share the static routes into OSPF. So can you tell me in the router's routing table, let us suppose this is the routing table. This is the routing table of the router. And there are so many entries, routing entries. These are the routing entries in the routing table. How do we define or how to know which particular route belongs to which protocol? Because every protocol is given some code. The router, whether it is you're using Juniper router or Cisco router or any other router, the routing table contains information about the routes that particular router can forward the data traffic. For example, we want to travel from one place to another place and we want to use the train. So what we do, we have to look up in the website which train can take us from this place to that place. Similarly, a router receives an IP packet. We have done here. So this router, this is, let us suppose this is connected to the switch. The router is connected to switch. And here we have one computer. And this computer user wants to send data to another user which is in the network 3. It's connected to, and I'm connecting one PC here. This is network 3 PC. So if you want to send data from, let's say this is computer A to computer B. So this is computer B, right? So when I send data, let's suppose the packet comes to the router. So router should look up in its routing table. So this is the routing table of that particular router. How do I send data to B? So it's like checking. So router can have any routing protocol. The data will not look at which protocol. Suppose I'm accessing yahoo.com or you're accessing google.com. Your computer send the request to your local home broadband router, or maybe if you're in the office, it will send to the office router. The router will not check which protocol is showing me the path. It will only see whether the route is available or not. It could be static route represented by S. It could be OSPF route represented by O. It could be RIP route represented by R. Or it could be EIGRP route represented by D. Or BGP route represented by B. So the router will not see which protocol is showing the path. It will only check whether the path is available or not. But when two protocols want to communicate, when two different protocols want to communicate, we have to ensure that the metrics are taken care. And while configuring redistribution into OSPF, there is an important parameter that we have to consider, that OSPF protocol has a limitation. I repeat, OSPF protocol has a limitation, and that limitation is that it can redistribute only classful networks. So now we have another question as to what do we mean by classful network, or what do we mean by classless network? Can somebody throw some light on that? What do you mean by classful network?
Default, the network which uses default mask is a classful network. The network which uses change of default mask, that is a classless network.
Very good. Yes. So if we consider the IP subnets, class A or class B or class C, if they come with the default subnet mask, they are called as classful networks, and only they are redistributed according to OSPF. So this is the condition we have to remember while redistribution. You cannot redistribute and then see that I didn't get the route. What happened? because OSPF very clearly defines what it can do. Okay, so we have seen the rules, and we have to now redistribute static routes into OSPF. So we will consider a small example here. And another important point apart from this classful network is that the OSPF will display in the routing table the routes are external. Means how does the OSPF know that this is learned from static route? So it will apply one small code which we will see now. It will apply a small code to the route, and we can differentiate how to know which is a pure OSPF route, which is a redistributed OSPF route. Okay, so here we have an router, an example of router 1 where we have created static route. So you see the first static route. This is the syntax, how to configure the static route. In the config mode, IP space route, then the subnet 192.168.10.0 followed by the default subnet mask, and this is the next hop IP address. So this is static route. If you look at the first example, this is class C network. This is a class C network, and this subnet mask also belongs to class C. So it is a simple static route for a class C network. And the second static route, if you observe closely, it is 172.24.1.0. So basically this is class B. And if you observe the subnet mask, see the subnet mask, is this the default subnet mask?
No.
It is not a default subnet mask, which means it is subnetted, it is classless. It's not classful, it is classless. Similarly, we have the third static route, which is class A 10.x, and the subnet mask also does not belong to class A. So this is also classless. So this is the static route configuration, and we have in the second part of the configuration OSPF configuration. Router OSPF, this is called as process ID. We can give any number, but there's a range. You can give 0 to 65535 or something. Okay, so it's called as process ID. So once you are in the OSPF configuration, we are giving command redistribute. This is the command to redistribute. And then we are specifying which protocol routes will be redistributed into OSPF. So whatever you give, the protocol we give after the redistribute command, those routes will come into OSPF. Maybe I could have given redistribute RIP. Maybe I would have given redistribute BGP. Example. Okay, we are not supposed to redistribute BGP routes to any other IGP protocols. It's very, very dangerous, especially on internet. Okay, so as per our requirement, redistributing the static routes into OSPF, first we must have the static routes on the router, which we have mentioned in the first part of the configuration here. And then we have OSPF configuration, and in the OSPF configuration, we give the command redistribute space static. So with this, we have configured static redistribution of the static routes into OSPF. Now we did this on router 1, which means we have to ensure that on this router 1, both OSPF is configured and static route is configured. Okay. Then we have in the output, after configuring the redistribution, we are checking, observing the output not on R1 router. Remember this. Whenever we configure the redistribution, we don't check the output on that particular router. We need to check this on the neighboring router. So we go to R5, sorry, yeah. So if you remember in the previous network diagram we used R1, R2, R3, R4 routers. So there on R1 router, we are configuring both static and OSPF. And in R5, we only have OSPF. Remember, in R5, only OSPF is configured. And those static routes which are available in R1 router, they are redistributed into OSPF protocol, and we are seeing the output in R5 router. And we have already discussed O represent, it is an OSPF route. It is an OSPF route. But if you look at, there is another code called E2, means it is called external type 2. E2 represents external type 2. External type 2, T2, type 1 and type 2, different. Okay. So this is the root 192.168.10.0. Remember, we had this in the static route in the previous page. Going to the previous page, you can see this is the static route which has been introduced into OSPF because it is classful network. Because we already mentioned in the rules saying only classful networks will be redistributed. Whereas we have the second and third root static routes, which are static routes, but they are classless and hence not redistributed into OSPF. So we have discussed the concept of redistribution, the conditions, rules we have to take care while redistribution, and specifically about static route into OSPF and the rules. Okay, so any questions here before we go to the next example of redistribution?
Is it 110 by 20 or 110 by 120?
110 by 20.
Always numerator will contain the AD value, administrative distance.
Sir, where the situations arise, sir, this redistribution?
Yes, good question. Yeah. So if we consider in the case of RailTel network, we have basically RailTel is a MPLS network. In MPLS network, we differentiate as core and edge. We differentiate the MPLS network into two parts, core and edge. And most companies, most organizations, in the core, they use X type of routing protocol. And on the edge, they use Y type of routing protocol. And between edge to edge, they always use BGP. They use BGP for edge to edge or end-to-end mapping of customer networks. They have to use BGP. No other protocol will support. So any MPLS provider, service provider, has to use minimum two different protocols. To the MPLS service providers. But similarly, we have internet service providers also. Yeah, Anandam, please go ahead.
Sir, morning we had a class, the IPGP, where the customers' networks are injected from P customer one end to P customer other end.
Okay.
That is a scenario, sir. Example.
Okay.
That is we can say.
Yes, exactly. Yes.
More on that part, sir, because this OSPF or RIP static, we don't have that type of scenarios in our railways.
Okay.
But we are learning this PLS now. This is important concept where we can understand.
Anandam, this faculty is nominated by RailTel, not by IRSET. You please keep in mind, let him cover whatever topics are told him to cover.
Sir, they are not
don't decide the topics. Let him continue with his proceedings, please.
More on relevant topics.
No. That we will see later. First, let him continue whatever he has done.
Yeah. Okay.
Please continue.
Yeah. Thank you. And I just want to mention, I have another topic tomorrow on MPLS layer 3 VPN. So I'll be covering that tomorrow. Okay. So now coming back, we have seen the example of static routes being redistributed into OSPF and how it appears within the OSPF routing table. How do I know that this route has been redistributed? By looking at E2 code, we know that it is a redistributed route. But by just looking at this output, we cannot determine it has been redistributed from static. It would have been redistributed from RIP or EIGRP also. We only know that it is a redistributed route. Okay, so this is for example 1. Yeah, I just asked if anybody has any questions on this. And Ali sir, please can you tell me what time I have to stop for question break?
Yeah, around 3:20.
3:20. Okay, another 5 minutes I have. Yeah. Any questions? I'll go to another example. After this also, we have some more time for questions. Okay. So this is example 2 of redistribution, where the roots of OSPF will be injected into EIGRP. Earlier, our example was static roots getting injected into EIGRP. Now, the second example that we're going to discuss is injecting the OSPF roots into EIGRP. So here we have two domains. I mentioned domains because there are two different protocols. EIGRP domain, all the routers here will run only EIGRP, and OSPF domain where all the routers will have only OSPF protocol. And one of the criteria, actually this example is evident for our previous example also. One router must have both the protocols for redistribution. Okay, there was a question, I'm sorry, Mohammed Ji. 110/20, yeah, I'll come back on that. I'll just go back to clear his question. See, numerator will always be the administrative distance depending upon the protocol. Every protocol will have its own administrative distance. Let's say, for example, RIP will use 120 default values. OSPF will use 110. EIGRP will use 90. BGP will use 20. First one is the administrative distance, which is fixed. The denominator is the metric, the cost of reaching that particular destination. So in OSPF, we have a formula 10⁸ divided by bandwidth in bits per second. So based on that, the calculation, this value will be derived. So 20 is the default value for redistributed routes. Remember, in our redistribution command, we have not mentioned any additional parameters, though they may be required for certain protocols. We just mentioned redistribute static. So which means it will use default parameters, default values. So whenever you redistribute RIP route into OSPF, EIGRP route into OSPF, the cost will remain 20 only. Static or RIP or OSPF routes, when redistributed, will have a default metric value of 20. Suppose we want to give any value less than 20 or more than 20, then we have to specify additional parameters in the configuration saying metric, so and so, metric, so and so, we have to specify. And when that value will be determined, so you may ask another question subsequent to this, what does this value signify? So basically, when data packet arrives on the router and router has to decide which is the best path to forward the packet, it will look at the metric values. Whichever metric value is better, it will push the packet via that path. Another example, suppose I'm walking on the street and I don't know to which place I want to go. I don't know the address. And you are standing on the street, and then I ask, hey Mohammed Ji, please can you tell me how to reach this destination? Then you will look at the address, and then maybe there are multiple routes via street number X, via street number Y. So you may guide me via the shortest path or the best path. Because you know that there are two routes, you will determine which is better and tell me. So similarly, the metric value, the denominator value is a metric to check which one is a better path, if there are two or more paths. Okay, am I clear?
How this is calculated?
These values are calculated based on the interface bandwidth available on the router. For example, the router has an interfaces, links, serial link, different links. That link will have bandwidth parameters. Check the show interface, that particular interface type. In that, there will be a bandwidth parameter. That bandwidth will be used in the formula I mentioned, 10⁸ divided by bandwidth in bits per second. So if there are 5 different paths to reach the same destination, among these 5 paths, which is better will be determined by the denominator value. And if suppose route number 1 was selected as the best path, and if that link fails, then that value will be removed from the routing table. Then among the 4 paths, whichever is having the lesser value, that will be selected and introduced into the routing table. That is the reason why we call them as dynamic routing protocols. Dynamically, the routes are changing. So for example, you want to go from, suppose you are in one place in one city, you want to go to the other part of the city. There are 5 different routes. and you travel in path number 1. Now there's a traffic jam. So you don't know, you started already. Now you are getting delayed. Okay, so similarly, routing protocols, what they do? When there are multiple paths available, each path value will be selected and kept in the routing table, but only display the best one. If that fails, then the next best one will be displayed in the routing table. And if that fails, the next best one will be displayed. To give you another example, we are accessing google.com, for example. When we type, we get the web page, but do we know from which path, how many paths are there to reach google.com? Definitely there will be multiple, but which one we don't know. The router will select based on these values. The router will select which is the best path. And if that path, are we sure that path will be available all the time, 24/7, 365 days? Not sure. The service provider may have link issues and that link may fail and it will go to another path. Just remember, you can do a trace route if you want. You can do a trace route from your computer. Let us suppose you are using Airtel internet, for example. You do a trace route and remember that path. Now go to your friend, or you can call your friend, ask him to do a trace route. Maybe he's using BSNL internet. So when you compare both, you will find different paths. What I am trying to say, suppose, do you see the screen, please? My command prompt, all of you?
Yes, we can see.
Yeah, I want you also to do the same thing right now with me. Trace RT space google.com. Here itself, we can know that we are using different routes to reach the same destination. Maybe we are in physically different locations. But if you're all of you are in the same city also, but if you're using different service providers, we will get different path. Oh, for some reason, I'm not being provided the information, but you can just check. The IP addresses will be different. Sometimes the network will not allow you to gather the information. Ping will come, but we will not know the path. Not sure if it still can access, but if this can connect, I can show you something good. Not able to. But in your case, can you see the trace route is showing you different IP addresses?
Yes. Yeah.
You can see that? Oh, okay. I can show you this tomorrow. In my tomorrow session, I will be able to give you more relating to MPLS as well as this also I will cover. I'll see I can give you more details tomorrow, Mohammadji. Okay, so now coming back into this example of the routes coming from OSPF into EIGRP. So these are the routes that are available. ENT1 router has these connected networks and these routes should go into EIGRP. That's the purpose. Whereas these ENT1 router and ENT2 router are running OSPF. These two are running OSPF. So these routes will come automatically into this router. But this router cannot send into this router because they don't have OSPF. But between this ENT router and remote router, there is another protocol, EIGRP. Because EIGRP protocol don't exchange routes into OSPF automatically and OSPF routes don't exchange into EIGRP automatically. Manually, the administrator has to push those routes via redistribution commands. So you can see ENT1 router is having only OSPF routes. Whereas ENT2 router, remember ENT2 router is like a bridge between the two protocols. On that router, okay, somebody has shown me the chat window, the trace. So if you can compare this with another user who has sent you this, it will differ because the paths are different. So ENT2 router, you can see both red routes are EIGRP routes, blue routes are OSPF routes. One router having both the routes. but it cannot share EIGRP to OSPF and OSPF to EIGRP by itself because it is not the feature available in that protocol. So only with the help of the concept of redistribution it is possible. So this is before, remember, before configuring redistribution, this is the output. So you can see on the ENT remote router, only EIGRP routes are present. OSPF information is not present. So while configuring on ENT2, remember, only on the common router where both the protocols are available, we can enable redistribution. So in the EIGRP protocol, we are specifying redistribute OSPF. Now, remember, I told you additional parameters are required for certain protocols. So this is the additional parameter required for EIGRP. Without this parameters, if you configure redistribution, the routes will disappear. So you may ask, what are these parameters? First one is bandwidth. Second one is delay. Third one is reliability. Fourth one is load. Fifth one is MTU. These are the 5 parameters. Remember, we had mentioned this earlier in one of our discussions. Yeah. Metrics of EIGRP, 5 parameters: bandwidth, delay, load, reliability, and MTU, 5 parameters. And all these 5 parameters must be configured while configuring redistribution.
What is MTU?
MTU stands for maximum transmission unit, which means the size of one packet. Suppose I am doing FTP. What is the size of one packet? I'm doing 1 GB data transfer. The whole 1 GB data cannot go as one packet. No, the computer will split it into smaller packets. And one packet, maximum default size, I'm saying maximum default size is 1500 bytes. 1500 bytes is the default. You can see the last parameter here, MTU 1500. 1500 bytes is the default maximum size of a packet. MTU, maximum transmission unit. So after configuring, this is configuring the redistribution on E2 router. Now when we check the output on remote router, look at this. This is the remote router. And I just want to bring to your notice, the highlighted routes did not exist before redistribution. Only EIGRP, pure EIGRP routes were present. Let me go back. Yeah. So only the D routes were present. Because this information is lot, I deleted them actually. C and L routes represent local. They belong to the local router. They were not learned routes. Okay. C and L represents local routes. They are not learned routes. Whereas D represents EIGRP learned routes. This is on the ENT remote router. But after redistribution, you can see DEX. EX represent redistributed routes or external routes. According to EIGRP, external routes. And they have been learned from other protocols. External routes. And that is why if you see the administrative distance value is 170. It increases. The EIGRP protocol automatically increases the administrative distance for redistributed routes. Default AD value for EIGRP is 90. See here, this is a default EIGRP learned route, 90. Numerator is 90. But for EIGRP routes, it is 170. This is the protocol's behavior. It automatically changes. It knows, hey, this route has been learned from another protocol, so it should not be as reliable as EIGRP route. So increase the administrative distance value. And as mentioned, the denominator is the metric, and the EIGRP metric calculations are totally different. There is a huge formula for that, so the values are different. For RIP, it's very simple and easy because it's just hop counts. How many routers it is hopping, it will just read that number 1, 2, 3, 4, 5. And the maximum hop count RIP protocol supports is 15 only. Okay. So you have any questions?
On which router this redistribution is applied?
Redistribution is applied on a router which is common for both the protocols. In this example, we have considered only 3 routers, but one router purely running OSPF, one router purely running EIGRP, and redistribution is configured on ENT2 router, which is having both the protocols. So that OSPF routes get redistributed into EIGRP. In fact, the example configuration we did was only one-way redistribution, meaning the routes of OSPF come into EIGRP. If we do two-way redistribution, then the routes of EIGRP can be learned via OSPF. And that configuration to be done also on the common router. In fact, tomorrow when we do the configuration of L3 and L3 VPN, MPLS L3 VPN, I will show you the demarcation point, like where we actually do the redistribution. Okay, any questions, please?
Thank you, Gangaraj garu. So, one normally this is not may not be exactly connected to your scope of subject, but some people have a lot of doubts regarding L2 VPN and L3 VPN.
Oh, okay. Tomorrow's topic is about it, sir. Actually, tomorrow's my topic is on.
Okay. So, if it is not your main topic, I just wanted you to spend some time on that.
Okay, got you, sir. Gotcha.
So, if it is there in the part scope of your syllabus, then that part many people are asking from the 2-3 sessions. L2 and L3 VPN part. So,
definitely, I'll throw some light on it and share my knowledge, sir. Yeah.
yeah. Thank you. Now we can break for tea. So we'll meet exactly at 15:45.
Okay, sir. Okay. And there was one question about parameter load. Okay, basically, load is on the utilization, link utilization, sir. How much load on the link? That is a parameter load. Transmit load, receive load is the parameters verified on the interface statistics.